Hey, welcome to the Explainer. When you're on a plane, hurtling down the runway for takeoff, the last thing on your mind is probably the pavement underneath you, right? Well, today, we're going to dig into why that very surface is so incredibly important. We're talking about something called the Boeing Bump Index. It's the crucial system that makes sure that powerful takeoff roll is safe and stable. So let's really think about this question for a second. It's kind of wild because we always focus on what happens in the air, don't we? But it turns out the ground itself can be a huge challenge. We're diving into the hidden world of runway roughness, and believe me, it's a massive safety issue that affects everything from the plane's landing gear to the pilot's ability to even control the aircraft.
And I want to be clear, we're not just talking about a little bit of a bumpy ride for comfort's sake. No. These are surface flaws that can create such intense vibrations in the cockpit that pilots can't read their instruments properly. Imagine that. It can make it tough to handle the controls or even just steer the plane straight during takeoff or landing, literally the most critical moments of any flight.
Okay, so let's get into roads versus runways. To really get a handle on this problem, you first have to understand that a runway is a totally different beast than a highway, and because of that, you just can't measure them the same way.
This right here really breaks down the key differences. Think about your car's suspension. It's built for comfort, right? To smooth out potholes on your drive to work. An airplane's landing gear, totally different job. It's designed to absorb a mind-boggling amount of energy during that one single moment of touchdown. And here's the really important part, the type of bumps they care about. For roads, we use something called the International Roughness Index, the IRI. It's great for picking up short, choppy bumps. But for an airplane, the real danger comes from these long, rolling waves in the pavement, some over 200 meters long, that your car would just glide right over without you even noticing.
Yeah, and this FAA quote really hits the nail on the head. An aircraft's suspension is like a specialized tool, a specialist that's designed for one single massive event, landing. It is not built to give you a smooth ride down a bumpy road. And that's exactly why even small-looking imperfections in a runway can become a huge problem for a plane.
So, you have this really unique problem, and it demanded a pretty ingenious solution. Let's talk about the virtual straight edge.
And this is where the Boeing Bump Index, the BBI, comes into play. Now, this is not a general-purpose tool like the IRI we use for roads. Think of the BBI as a highly specialized detective designed for one mission: to hunt down those specific, single, isolated bumps that can send a massive jolt through a huge airplane that's moving at incredible speed.
The whole idea behind it is actually, brilliantly simple. Just picture this. You take a long, perfectly straight but totally imaginary ruler, a virtual straight edge, and you lay it over a profile of the runway. The entire BBI method just boils down to measuring how far the actual runway surface dips or rises away from that perfect line.
So it's actually looking at two things. First, you have the bump height, which is exactly what it sounds like. How high is the bump? But just as important is the bump length, which tells you how far along the straight edge that bump is located. And here's the genius of the BBI. It recognizes that it's the combination of height and length that really determines how bad of a jolt an aircraft is going to feel.
All right, so we have these measurements. How do they turn into a single, easy-to-understand score? Let's get into calculating the BBI score.
Okay, it's a pretty rigorous process. For basically every single point along the runway's profile, a computer program runs through all the possible straight edge lengths and positions. For each one, it finds the biggest deviation, the worst bump. Then it compares that real-world bump to a chart of what's considered acceptable. The final BBI for that spot on the runway is simply the single worst ratio it finds out of all those thousands of calculations. It's designed to find the absolute worst-case scenario.
And what's great is that all of that complex math boils down to one simple magic number. If the BBI score is less than 1, you're in the clear. The bump is considered acceptable. But if that score creeps over 1.0, you've crossed a line. That bump needs a closer look. It's a beautifully simple, actionable result.
So what does it mean to pass the test? Let's look at the official rulebook for grading a runway. How do these numbers translate to the real world?
In this chart, this is really the heart of the whole BBI system. It's simple. You've got the bump's height going up to side and its length along the bottom. And what this does is create 3 distinct zones. And depending on which zone a bump falls into, it literally determines the fate of that runway.
First up, we have the acceptable zone. This is where you want to be. It's the standard for any new runway construction, and it means everything is considered safe for all planes all the time.
Then you move into the excessive zone. Now this is where things start getting, well, excessive. The flight crew and passengers can feel it. It can start to cause some minor steering problems, and it puts extra wear and tear on the aircraft. At this point, repairs are definitely on the table.
And finally, you have the unacceptable zone. And this is serious. If a bump falls into this category, it's considered a direct threat to the pilot's ability to safely control the plane. The response is drastic and immediate. You close the runway. Period. No flights until it's fixed.
So, let's just recap the big picture here. These categories, acceptable, excessive, and unacceptable, they aren't just friendly suggestions. They drive real-world, high-stakes decisions about maintenance, about money, and about whether a runway is even open for business. It's a huge deal.
But is that the whole story? What happens when the BBI says a runway is fine, but pilots are saying something completely different? Let's look at whether this is an incomplete picture.
Well, it turns out some experts are saying, hold on a minute. They argue that while the BBI is a fantastic tool, it might not catch everything. This quote from EPR consultants warns that if you rely only on the BBI, you could actually miss a really serious problem.
And this case study is the perfect example. It's fascinating. On one side, you have the BBI analysis of a runway. The software looks at the bump and says, yep, this is acceptable. But pilots were constantly complaining about this exact spot. So they ran an aircraft simulation over the very same bump, and the result on the other side tells a completely different story.
So what did the simulation find? It predicted a vertical acceleration in the cockpit of 0.88 g. To put that in perspective, that is a massive jolt. It's almost the full force of gravity, pulling you straight down instantly.
And a jolt like that is a huge problem. It's officially considered unacceptable by Boeing because it can make it incredibly difficult for pilots to read their instruments clearly. And this really shines a light on a potential blind spot for the BBI. Because it's so good at finding single, isolated bumps, it might sometimes miss the combined dynamic effect of several smaller bumps in a row.
So this leaves us with a really important question, right? If a simple number can't always capture the full story, how do we measure what a pilot truly feels in the cockpit? It seems the future of runway safety isn't about replacing the BBI. It's a fantastic, vital tool, but it's about pairing it with things like advanced aircraft simulations to get the complete picture. You have to combine the math with the real-world physics to truly understand what's going on. Thanks for watching.